I'm starting just in 1 minute. Okay. Hello.
Assalamu alaikum, sir.
Walaikum assalam. Okay. So any doubt from the last class?
No, sir.
Khalid?
No, sir, no doubt.
So what you had learned in last class? Graph, I think.
Yes, sir.
Oh, I remember. I have given you one question. Hamza,
Yes, sir.
have you solved?
Yes, sir.
Just tell me. I'm giving you just 1 minute. I will ask. The first graph was like I think this one. Okay. And the second one was is it the first one or there was some other graph?
No, sir. And this was second one.
So the first one was like this. Khalid,
Yes, sir.
whether I have given in homework like this, or some other graph.
Like from y-axis.
So I think it will be like this. Okay, Hamza? Whether it was similar to this? Iba?
Yes, sir. It is one of the four you have given.
Okay. So the next part is, I have given 4 graphs or just 2 graphs.
Sir, four.
I had explained you 2
Only
graphs
2.
and given you the rest of 2. Just 1 minute.
2 you explained and 2 for homework.
Yeah. These are 4 different graphs for which I had explained you 2 of these 4 terms. Just this is first, third, second, third, and fourth. Khalid, tell me which one I have explained. First, second, third, fourth. Hiba,
The first and fourth you explained, and second and third you gave for homework.
good. So first and fourth I had explained you, and second and third you have to solve. So now just tell me your answer. For the first part, whether the slope is positive or negative. Hiba, I had defined you to define slope at any curve. Just try to
It is
draw a
negative.
tangent. Good. So the first part, draw a tangent over here. Similarly, draw a tangent over here. On the basis of them, draw a horizontal line and draw a horizontal line. So this is going towards downward in clockwise. So that if there is an angle which is measured in terms of clockwise, it should be taken as negative. So it will be negative. It will also be negative. So the slope of this particular graph is negative. Now, this will be your theta1 minus, and this will be your theta2 minus. Whether this particular slope is increasing or decreasing. Hamza, whether this particular slope is increasing or decreasing.
Sir, decreasing.
Decreasing. No, in terms of magnitude is just increasing, but there is negative sign, so we can call it as decreasing. Good. Now to define third part, just draw a tangent over here. Similarly, a tangent over here. Now just draw a horizontal line over this point and a horizontal line over this point. And take your angle from this axis, Salman, tell me your answer, whether this particular slope is positive or negative. Okay, Khalid. Okay, I have just asked you whether this particular slope is positive or negative. Khalid, will you define?
Yes, sir.
Just tell me.
It's third one. Okay, it's negative.
Good. So it will be negative theta1 and it will be negative theta2. Now, Heba, tell me whether this particular slope is increasing or decreasing or becomes constant.
Decreasing.
Here, theta1, if you just take the magnitude, just neglect this particular sign. So theta1 is greater than theta2. Okay.
Yes, sir.
So theta1 is greater here. So on moving from this point to this point, whether the slope is increasing or decreasing, it's decreasing. But if we multiply it by negative sign, your answer would just reverse. So we can call it as it increasing. Okay.
Yes, sir.
Now it is clear to everyone, this whole four graph. Hamza,
Yes, sir.
Salman. Okay. So we have defined all different types of graphs. Now we have certain graphs and the area and the slope of that particular graph will define you something term. The first one is slope of first distance time graph, displacement time graph, speed time graph, and velocity time graph. First, I'm asking about the slope, which means just divide these two terms or take perpendicular over base. So for defining the distance time graph or the slope of distance time graph, you have to just divide these two terms. So it will be distance upon time and it will give you nothing but speed. So we can say slope of distance time graph will define your speed. Similarly, Hamza, tell me the slope of displacement time graph. Which quantity will be depicted by the slope of displacement time graph? For any of the relation, for the slope, just divide these two terms. So it will be nothing but displacement upon time. So which quantity will give you or will be related as displacement upon time? Hiba?
Sir, velocity?
Good. Similarly, speed time graph gives you acceleration and velocity time graph will gives you acceleration. Okay. The next part is to define area under. For area under the graph, just multiply those two terms for which we are taking area. The first part is acceleration versus time. So we have two different segments, acceleration versus time as modulus or acceleration versus time as simple. Acceleration versus time simply will define you the product of acceleration time and will define you just velocity. But if you take the magnitude of that particular term, so magnitude of velocity will gives you speed. Okay. Similarly, velocity time graph, area under velocity time graph gives you displacement. But if we take mod of this particular part, I'll define you distance. So it is nothing but displacement and is nothing but distance. And the last part, area under speed time graph. It will define you distance. So these are some terms related to the area and graphs representing some other quantities. Is it clear to everyone?
Yes, sir.
Hamza,
Yes, sir.
just write it down.
Sir, done.
Have you all written?
Yes, sir.
Okay, on the base of these terms, I'm giving you some problem and defining you how to solve them. First, this is your velocity and this is your time. This is 20 meters per second, 5 seconds, 9 seconds, 11 seconds. Suppose this is your O, A, B, and C. We have to find acceleration for OA, AB, and BC. Similarly, displacement for whole part. And then third part is velocity at 4 seconds. Now, the question is how to solve. Just see, this is your velocity time graph. So I had just defined you back. We can define two things for a particular graph. First, we can calculate slope and we can calculate area under. The first part is we have to define acceleration. So just try to relate velocity time graph to find acceleration. So here is your relation. Slope of velocity time graph will gives you acceleration. Okay? Okay, Ba?
Yes, sir.
So from this, we can define the slope of velocity time graph will gives you acceleration. Now the question is how to find slope for this particular part. In the previous lecture, I have defined you to find the slope by 3 different ways. First, if there is angle given, just take tan theta. If there is a coordinate given, just take coordinate like here we have 0, 0. If we define coordinate for A, x coordinate is 5 and y coordinate is 20. So we can write 5, 20. Similarly, for the coordinate of B, the x coordinate is Hiba. For defining the coordinate of B, the x coordinate is
09.
for defining B, coordinate of B. I'm not defining the coordinate of this. So B has x coordinate as 9 and its y coordinate as
20.
good. Similarly, to define coordinate for C, here x coordinate is 11 and there is no y coordinate as it is lying on the x-axis. So I had just defined you all the coordinate. So to find the slope, the formula is y2 minus y1 divided by x2 minus x1. Now, for the acceleration of OA, just write acceleration between OA. Just take the line OA. This would be your final point, means x2, y2, and this would be your initial point, x1, y1. Just put all the values in this particular term and try to obtain acceleration for OA. Okay, Khalid?
Yes, sir.
Hamza, any doubt?
So can you tell me tell again what is Y2?
Suppose this is your line OA. So it is starting from O. So we can call it as X1, Y1. And it is ending at A. So we can call it as X2, Y2. Okay.
Okay, sir.
Just put their values and try to obtain the slope for OA. Have you solved for the first part?
No, sir, doing.
Salman, are you solving? Good, Khalid. MashaAllah. Try to relate displacement with this particular graph from the previous section as I have explained you. We have to calculate displacement for the whole, and there is a relation between calculation of displacement with respect to velocity time graph. Okay, Khalid? Just
Okay,
try
sir.
to compare. Okay. Hiba, should I help you? Just see for the first part, suppose for OA. Here Y2 is, Hiba, tell me.
20.
Good. And y1 is
0.
good. X2 is
X is 5.
good. And x1 is 0. So just to simplify it. So it will be nothing but 20 divided by 5 and it will gives you 4 meter per second square. Okay, Hamza?
Yes, sir, I have done that.
Salman? Similarly, try to obtain the other part as well for AB and BC. Good, Salman.
Sir, I got stuck in the second question. Can you explain how to do it again?
Just see, we have to calculate displacement and there is velocity time graph. So just see this particular section. What is written here? The area under velocity time graph will gives you displacement. Okay. So you have to just calculate the area of this whole geometrical part. Okay, Khalid?
Yes, sir.
Hiba, have you solved the second part? Acceleration for AB. Hamza,
Yes, sir.
just send me your answer. Hiba, have you solved the second one?
Yes, sir.
Tell me your answer or send me your answer. Good. Hiba. Third one. Khalid, your answer is incorrect. Salman, send your answer. Yeah, Khalid, just use trapezium formula. Good, Hiba. Let's now solve second one. That is displacement with the four hole. For the use of or for calculating displacement, we have to define the area under the graph, that is velocity time graph. Now it's correct, Khalid. Hamza, have you solved?
Sir, which one?
Second one, displacement.
No, sir, doing that.
Acceleration for these three segments.
Yes, sir, done.
Acceleration for ABS,
Sir, 0.
good. And acceleration of BCs,
Sir, -10.
good. Try to solve displacement. Khalid, try to solve this part.
Okay, sir.
Salman, you got the same answer for acceleration? Good. Just try to solve the second part. For the displacement, just calculate the area bounded by this particular curve. Okay, Salman, no problem. Hamza, which geometrical figure this particular term is representing?
Sir, trapezium.
Good. And what is the formula for calculation of area of trapezium?
Sir, half into A plus B into height.
What is A plus B here?
The sides.
No, the parallel sides.
Yeah, the parallel sides.
So from this particular geometrical figure, the parallel sides is this and this. Okay. So this is of total length 4, and this is of total length 11. Okay.
Yes, sir.
And the separation between these two lines is the perpendicular distance from this point to this point. It is nothing but just 20. So we have A as 2, B as 11, and H is 20. Okay, Ba?
Yes, sir.
Just put all the values and try to calculate displacement, which is equals to area under trapezium graph half sum of parallel sides into height. Hello.
Yes, sir.
Was something bad due to some Wi-Fi problem. So have you all calculated the last one? Hamza? We have defined the area of that particular curve. Now, how to calculate that particular velocity at 4? I'm defining with that. There was a line extending from this point to this point. Similarly, a line from this point to this point. And it's going like this way. We had to define velocity at 4 seconds, but there was given at 5 seconds, velocity is 20 meter per second at this particular line. Velocity versus time. So I can define from this particular graph, initial velocity of that particular body would be nothing but, Hamza,
0.
at time t is equals to 0. So we can define initial velocity of the body is 0. And acceleration for this particular graph is nothing but 4 meter per second square. So we have to calculate velocity at t is equals to 4 seconds. Just use equation of motion and try to obtain velocity final. Okay, Eva?
Yes, sir.
This is one way to solve. There is another way to define it. We have to define velocity at this particular instant, 4 seconds. So if I draw a line this and draw a line at this point. So if this is a straight line, slope at each instant would be equal. Slope at this point, slope at this point, and slope at this point, all would be equal. So while taking the slope from this point to this point, while taking the slope from this point to this point would be equal. So it has x coordinate as 4 and take y coordinate as v. So it would be y2 minus y1 by x2 minus x1 is equals to 20 minus 0 divided by 5 minus 0. So it will gives you v by 4 and 20 by 5. So v is equals to 20 into 4 divided by 5. 5 fours are and 4 fours are. So either you just compare the two slopes at two different instants or just use equation of motion to define that particular value. The choice is yours. Okay, Khalid?
Yes, sir.
Just try to simplify using equation. Salman, any doubt? Hamza, have you done using this particular equation?
Yes, sir.
What is your answer? Is it the same?
Yes, sir. 16.
Hiba, you got the same answer? Khalid?
Yes, sir. Got the same answer.
Good. I'm giving you one more problem. Here's a graph related with acceleration versus time for a body whose initial velocity is 5 meters per second and acceleration is going like this way. So how to define final velocity from this particular graph? We have learned a relation. Acceleration is nothing but change in velocity over time taken. Okay, or we can simply write it as b minus u divided by time taken. Now, if you bring this particular t to the left hand side, it will becomes a into t is equals to b minus u. Now, we have to define this particular quantity using this particular graph. I had explained you once, if a quantity is related by product of any two different quantity, it would be represented by three different means. First, whether numerical value is given, so just multiply them. If graph is given to calculate that particular product, just take the area of that particular graph. So we have graph A versus T, and we have to take the product of that particular term. So just take the area of that particular graph and put it here. We have initial velocity as 5 meters per second. On putting all of them, we would be able to calculate final velocity. Is it clear to everyone?
Yes, sir.
Hiba, any doubt?
No, sir.
As we had a relation for the calculation of acceleration, acceleration is nothing but rate of change of velocity, or we can simply write it as change in velocity over time taken. If question says you the initial velocity of the body is 0, so we just take the area of that particular acceleration versus time graph, it will give you velocity. But in actual sense, it will give you change in velocity according to the formula. Okay, Khalid?
Yes, sir. So we have to find the area of that figure right now.
Yeah. So we have to calculate area of that particular figure. It is depicting nothing but a triangle, and the area of triangle is nothing but half base into height, and put that particular value here. We have initial value as 5 meters per second. Put it here and solve them to find V. Good, Khalid. Hiba, have you solved the area of the graph? Hamza,
Yes, sir.
tell me your answer. This is nothing but a triangle, and area of triangle is nothing but half base into height. We have base 10, we have height 10. Just put them here. It will give you A into T. We have U. Just put them here and rearrange. It is just your area under the graph. Just put the value of U to find B. Hiba, it is just your area. You have to calculate B. Just put the value of U and simplify it. A into T is nothing but 50. B we have to calculate, and U is nothing but 5. If we bring this particular to the left hand side, it will become 55. Okay, Hamza?
Yes, sir.
Hiba?
Yes, sir.
Okay, so we have done how to define slope and how to calculate these particular terms representing that particular slope. Now, how to draw any graph depicting some situation. For any of the calculation, just try to figure out graphically. If you able to draw the graph representing that particular situation, you would be definitely able to solve any of the problem very easily. I'm giving you one question. From station P, a train starting from rest accelerates at 4 meter per second square to attain maximum velocity v. Then decelerates at 2 meter per second square and comes to rest at station Q. If total time taken for journey is 30 minutes. Find V distance between PQ.
Sir, what did you write there? Starting from rest accelerates at 4 meter per second?
Accelerates at 4 meter per second square.
Oh, okay, sir.
And on attaining some maximum velocity v, it starts decelerating at 2 meter per second square and comes to rest at station Q. So here the question is in terms of velocity and time. So it will be better to draw a velocity time graph representing this particular situation. The first part is the train is accelerating. It means the slope of velocity time graph would be positive for the first part. Let's say from this point to this point. Then it starts decelerating to comes to rest at station B, Q, like this. So this is your time axis and this is your velocity axis. And this will be your maximum velocity according to the situation or according to the given. Let's call it as V or V max. The total time taken for this entire journey is 30 minutes. This is your acceleration for the first part. Let's say it is alpha, which is equals to 4 meter per second square. And this is decelerating from this point, negative acceleration. So let's call it as beta as 2 meter per second square. This is the whole question. Hamza?
Yes, sir.
So what we have to find out, we have to calculate velocity. So we first need the time for this particular peak. Okay. So the first part is to take this particular time from this point to this point as small t. Rest of the whole part would be total time minus of this. So this is your 30 minutes. So convert it into seconds. It will give you 600 seconds. No, 1800 seconds. So it will be just capital T minus small t. I have taken this particular time as capital T. Is it clear to everyone?
Yes, sir.
Any doubt? Hiba?
No, sir.
I have just break this particular graph into two parts. Since I have to calculate Vmax, so I have to calculate the time for this particular interval. So I have drawn a vertical line for this and taken this particular interval from this point to this point as t. So the rest of other part will be total time minus t. Okay, Khalid?
Yes, sir.
Now we have two sections. First section is this much, for which the body is accelerating from rest and its final velocity is nothing but v. So using first equation of motion, we can use v max is equals to u plus a into t. Let's say this is your equation number 1. Now for the next part, while decelerating from this point to this point, just tell me what is the initial velocity and what is the final velocity for this green line. Iba? While decelerating from this point to this point, what would be the initial velocity of the train and what would be the final velocity of the train? The train has finally stopped at the station Q. So it means final velocity would be
0.
good. And initial velocity would be nothing but V max.
Yes, sir.
Okay. So using first equation of motion, V is equals to U minus as it is decelerating. So we take acceleration to be negative. and time for that particular interval is nothing but t minus t. So if I rearrange, V max becomes beta times t minus small t. So we have equation 2. Both these two equations have same left hand side. So just equate them right hand side and try to obtain the value of small t. First, write it down. Khalid, any doubt in this product problem?
No, sir.
Good.
So now we have to solve these equations, right?
Yeah, we have equation first and we have equation second. Since the two equations have same left hand side, so just compare them to find the value of a small t. On getting a small t, put that particular value of small t in the first equation, you would be able to calculate V max. Have you simplified, Hamza?
Sir, doing it.
Okay, just equation first and equation second, compare them and try to obtain the value of small t. We have the value of alpha, value of beta, and value of capital T. Good, Khalid. T is just capital T by 3. Capital T is 30 minutes, so small t would be just 10 minutes.
Oh, sir, I did not notice the capital T.
Okay, no problem. Now just put the value of small t in first equation of motion. We have alpha also. So try to find V max. Time is in minute. Just convert that time into second. Khalid. Iba, have you solved the first part? Just compare these two equations. It will be alpha times t is equals to beta times capital T minus of beta times small t. Bring this particular part to left hand side. It will be alpha times t plus beta times small t is equals to beta times capital T. If I take out common as small t, alpha plus beta, so t would be nothing but b upon alpha plus beta. Now put their values. Beta is just 2, alpha is 4, and capital T is 30. Okay, Ba?
Yes, sir.
Just put their value and try to obtain small t. Hamza, you got the same expression?
Sir, I have done the mistake in the last part.
Okay. While taking the coefficient to be common.
Yes, sir.
Now, or obtaining this particular value of t, put this particular value in first equation here. You would definitely find B max. Salman, do you have any doubt? Yes, Hiba, how much you got the answer for small t? Here we have beta, which is equals to 4. Capital T is 30. Divide by alpha, which is 4, and beta. Here we have beta, just 2. Beta is 2. Alpha is 4 and beta is 2, so it becomes 6. 6 5 so it will becomes just 10 minutes. If you put this particular value of t in this particular first equation, just convert this particular unit into second by multiplying it by 60. So it will become 600 second. Good, Hamza. Khalid, have you solved the rest part? Good, Hiba. So we have done Vmax. Now the next part is to calculate the distance between P and Q. We have velocity and time graph. How to calculate displacement for this particular graph? We have just defined you. Area under velocity time graph will gives you displacement. So just try to take the area of this particular entire region. For this entire region, we have base as capital T and we have perpendicular as Vmax. So area under this graph will be just the area of the triangle. Okay, Khalid? This is depicting our triangle and area of triangle is half base into height. Base is the total time taken, which is 30 minutes. So just multiply it by 60. And h is Vmax. As we have calculated, it is 2400 meter per second. Okay. Khalid, you haven't calculated the term in their SI unit. You have to first convert time from minute to second. So it will be S is equals to half 1800 into 2400. This whole term will gives you in terms of meter. So if I divide this particular whole term by 1000, it will convert into kilometer. Is it clear? Now this 30 would cancel out from this. This 2, 12, 12 8 times 96 and 12 1 times plus 9, 21, 0 kilometer. This would be your final answer. Okay, Hamza?
Yes, sir.
Hiba, any doubt?
No, sir.
So this is a special problem. This was, I'm defining with the result regarding this. If a body is accelerating by some acceleration alpha, and if it is decelerating by, let's say, some beta, so there is some direct relation. Time taken for this particular journey is t. This quantity is B max, and the area under this graph gives you the distance traveled between two different journeys. This is your time to get maximum velocity, let me call it small t. So small t was beta times capital T by alpha plus beta. So V max is equals to alpha times beta into beta t upon alpha plus beta. S is equals to half alpha beta t square divided by alpha beta. Okay. So this is the consequence of this particular question. Okay, Hamza.
Yes, sir.
If you put directly the values in this equation, you will definitely get the result in just 1 or 2 seconds. Hiba, any doubt?
No, sir.
Salman? So here we have just finished all the graphs related problems. So we have finished this whole part. So just let's stop here. I will continue in next class, the relative motion, and then we will start 4th chapter, that is motion plane or vector. Okay.
Okay, sir.
So just